Morning, everyone. So I woke up this morning and somebody had made a comment on a post that I had previously commented on. The original post was about Surds and how to best teach it what everybody else does, and what are some really great ideas on how to get kids to understand it, because it can be quite tricky. It's quite an abstract concept, and a lot of us struggle with actually getting the kids to really get what's going on when we simplify Surds. So I thought, while I'm sitting in the car waiting for my coffee, I would put together this video and show you more examples, because the person commented and asked for more examples because they found the models that I'd used quite interesting. So here we go. I'd love to hear your thoughts. Let me know what you think. Here we go. The first example that I used was simplifying the Surd 18. Now, the first thing you want to get the students to do is always to find all the factors of 18 first, so that they can start to identify whether there are any square numbers that make up the factors of this number. And you can see here that there is a square number, and that square number is 9, right there. Now, one of the most important things you want the students to already have had a lot of practice in before they even contemplate simplifying Surds in this way is using arrays to find factors and multiples, but also working a lot with square numbers and square roots using arrays. If we did this for 9, it would look like this. Now, for this array showing 9, the area represents the square number itself, and the square root represents the side length, which is 3. Now, we also know that 18 is made up of 2 groups of 9. Now, rather than representing 18 as 2 rows of 9 or 2 rows of 9 columns, we can represent it as the sum of 2 square numbers like this. So you can see here that we've moved back into that groups of model, where we've now got 2 groups of 9, 9 being that square number. And 9 plus 9, or 2 groups of 9, gives us 18. But we want to know what the square root of 18 is in simplest form. So essentially, we want to take the square root of this groups of model. Now, we can rewrite the square root of 18 in this way and then simplify it like this, with the square root of 9, or 3 times 3 being 3, and the root 2 not being a rational number, so it can't give us a whole number value when we square root it. It remains as is, and that is root 2. So the Surd 18 in simplest form is 3 root 2. But let's get back to our arrays to show how we can do this using our model. So if we go back and take a look at this, we can see that each one of our 9s is going to give us a square root of 3, which becomes this part of our simplified Surd. But we've got 2 groups of these, so when we complete the simplification, we're going to get this. And you can see how the model connects straight back to that abstract type working. Let's do another example, and hopefully you'll start getting the hang of this. Let's take the square root of 12 and try to simplify that, place it in simplest Surd form. So we want to start by finding all of our factors. And here they are. We've got all of our arrays. Now, remember, the next thing we want to look for is, are there any factors that are square numbers? And yes, there are. 4 is a square number. Now, remember, the next thing you want to do is you want to represent this 12 as its sum of squares. So the squares have to be the same number, remember? So we've got 3 groups of 4, means that we can redraw 3 times 4 as 4 plus 4 plus 4, or to simplify our Surd using this method, we need our radical sign, obviously. We know that our square root of each of those 4s is going to be 2. So for our simplified Surd form, 2 is the square root of 4, which means this. And the 3 groups represents that second factor, that if we take the square root of 3, it's not a rational number, cannot be simplified. So that goes right in there, which gives us 2 root 3, which is root 12 in simplest Surd form. Let's do one more example. This time I'm going to simplify the square root of 80. And here they are. I haven't used arrays this time just to save space and for brevity, but the next thing you want to do, remember, is you want to get them to pick out any square numbers. And in this case, we've got 2 square numbers, and you want to get them to choose the highest square number. And the reason for this is because 20 also has factors 4 and 5, where 4 is that square number as well. So this is the reason why it's so important to get kids to have a play around and get their hands dirty with factors and multiples, particularly square numbers with factors and multiples, before they attempt this type of concept. So we're looking at our 2 factors, 5 multiplied by 16, and we want to redraw them in our groups of models. So we're going to draw 5 groups of 16 squares. So here we go. And there you have it, and we want to find that in simplest surd form. The square root of each one of those 16s is going to be 4, and we have 5 of those groups, so that means that the final answer of root 18 in simplest surd form is 4 root 5. And there you have it, 3 different examples of how to use visual models to simplify your surds.